Okay, so I said chapter 2 deals with measurements and unit conversions. When I say unit conversions, you have any idea what I'm talking about when I say that? Give me an example of a unit conversion. Yeah, centimeters to meters, inches to feet, right? Anything that I'm just changing the unit of it, that's called a unit conversion. So let's go back even a little bit more of a step. What is a unit? What does it mean to be a unit? Yeah, right. It's the label that goes on a number that tells us what are we measuring this number in, right? If I go out and measure something to be 4 centimeters, but I just write 4, I don't know. Is that 4 inches, 4 centimeters, 4 meters, 4 miles, 4 whatever, right? We don't know that unless there's a unit that goes behind it. So we're going to start looking today at the metric system, okay, or the SI system. Have you heard that term before? Metric system is also called the SI system. I'm going to actually start my notes here, okay? The metric system is actually called the SI system, and SI stands for System International, okay? It stands for System International. Or it's also just called the metric system. Okay? Most other countries in the world use the metric system, except for the U.S., right? There might be a couple other that use their own measuring systems, but I don't know what they are off the top of my head. What's the U.S. system called? Does anybody know?
Is it like the imperial system?
The imperial system, right? The imperial system is what ours is called. So let's think about how the U.S. measures length. What are some units that the U.S. measures length in? Inches, what else? Feet, what else? Yard, mile, right? All of those things are ways we can measure length. Now, what's the connection between those? How many inches are in a foot? 12. How many feet are in a yard? 3. How many feet are in a mile? 5,280 feet in a mile. Do those have consistencies between them? No, right? None at all. So learning the imperial system or learning the U.S. system is extremely difficult because there's no consistency. Okay, think about how we measure volume, cups, pints, gallons, right? Neither of those really have consistencies either, right?
How about ounce?
Yep, ounce it can either be a volume measurement or a mass measurement, a weight measurement. Okay? That's another thing, right? Why is ounces used in both places, right? There's fluid ounces and regular ounces, right? So the imperial system is crazy. Why do we learn the metric system then? Okay, the metric system gets used in science so that it is universal, so that it's the same throughout every country. So if I take measurements and I input my, or I publish results of an experiment, if mine results were in inches or miles per hour or something like that, no one else around the world would have any concept of what that means, right? So we adjust science findings to the metric system. So that's why we learn the metric system in our science classes, okay? So we call it the SI system or the metric system. They use 7 what are called base units, 7 base units. And these units are what these measurements are most commonly measured in. I'm going to tell you kind of a difference between the base unit and a simple unit. I have kind of a difference between those two. But the base unit is what these things are measured in. So here are your base units. For length, it should be always measured in meters, or it's most commonly measured in meters. And then I've got the abbreviation for it that goes beside it. Okay, so it's meters, but it's used a lowercase m to display meters. Next one is mass. Its actual base unit is called a kilogram. Kilogram. Okay, I want us to kind of understand here the difference between a base unit and a simple unit. The simple unit for mass would just be grams, right? And then kilo, does anyone know what kilo is called? It's a prefix, right? It goes before to describe the number of grams that are there. So the simple unit for for mass is really gram, but the base unit they call is kilograms. And the reason that we use kilograms more often than grams is because grams measures a really tiny amount of substance. And so if we were trying to take measurements using grams, all of our numbers would be in the thousands, right? We would take measurements and we would say, this weighs 4,300 grams, or it weighs 50,000 grams, right? Which that gives us kind of just inconvenient numbers, right? But if we measure things in kilograms, now we can say, oh, it's 4.3 kilograms, or it's 15 kilograms, or whatever. So the only reason we use kilograms more often than grams is because it's generally a more acceptable or a more convenient measurement for us, okay? So we'll look at that in a little bit. Time is measured in seconds. You'll sometimes see it abbreviated SEC, but you really need to get used to just having it be an S, okay, for seconds. And then temperature, that's measured in Kelvin, not Celsius. Celsius is a common one for non-US countries, but the scientific one is actually called Kelvin. Have you heard Kelvin before? A little bit. It's kind of bizarre because you don't call it degrees Kelvin. It's just Kelvin. It's kind of interesting. All right. The amount of a substance that we use is called moles. That's very specific to chemistry, and we will deal with moles a lot. But the amount of substance is moles. Now, there's a difference between the mass of something, how much it weighs, and the amount of something, okay? So when we talk about the moles of a substance, it's really giving us a better idea of the quantities, like how many individual molecules of that substance is there. That's really what moles kind of tells us. All right, and then two that we don't see very often are luminous intensity. That's really called candelas. What do you think that means? What do you think luminous intensity might mean? Like how bright it is, right? How bright a light is. And they're measured in candelas. What do we typically measure light? I don't know. What do we usually see in terms of light usage? Not candelas, but watts, right? Watts has more to do with the electric part of it. Not candelas. Sometimes you'll see candelas like on boxes of light bulbs and things like that, but it's most of the time just watt. And then the last one is electrical current. We measure that in amperes or amps. Have we heard that one before? Okay, so these are the 7 base units. They are all also considered simple units, except for kilograms, right? The simple unit for mass is grams. So we would add other prefixes to grams to see that adjustment, okay? But the base unit for the metric system for mass is actually kilogram, okay? So I'll call the other units kind of simple units, and then these 7 are considered base units. That's a very common term, so. Let's look now at the prefixes, and I gave you this table, so you don't need to copy this into your notes. This will be a table that I'll usually allow you to use on tests and quizzes and things like that, so you won't need to memorize it. We will get familiar with them enough that you'll start to memorize them, but you don't necessarily have to. What I want to talk through here is how I set the table up, okay? I like the table to look like this here. I've got the simple units listed. It could be mass, could be grams, liters, could also be seconds, right? Could also be amperes or whatever simple unit you want to use, but it could be any unit that sits right there, okay? Then above that, we tell how many of those simple units are found in a kilo unit. How many of the simple units are found in a mega unit, okay? So let me give you an example. If I had a 1 megagram, that would be equal to 1 million grams. 1 million is the same as 1 times 10 to the 6th. Okay, we're going to work through scientific notation, but if we were talking about scientific notation, how comfortable do we feel with that? A little bit? Okay, very good. Okay, so 1 megagram would be equal to 1 million grams. 1 megameter would be equal to 1 million meters, right? Do you see how the prefixes can apply to every type of simple unit? Yes or no? Okay, yes. So these above the simple unit are units that are larger than the simple unit, right? A kilometer would be equal to 1,000 meters. But the things listed below are units that are smaller than the simple unit. So I have the table formatted the other way to say 1 simple unit would be equal to 10 deciunits. One regular unit would be equal to 100 centiunits. So if I were going to use this example in meters, I would say 1 meter is equal to 100 centimeters. Okay? How many centigrams would be in a gram? 100, right? It applies the same way. The unit right here called micro, that might be a little bit hard to see. We draw it like a U with a tail on the front. Okay, that's how I draw micro. It's a Greek letter, okay, but it means micro. Because we can't use an M anymore. We can't use another lowercase and uppercase M are both already taken, so this is a Greek letter called micro. These are not considered base units, but they're other units that we use really often. So for volume, these are 2 units that are actually identical. They represent identical amounts of substance. 1 milliliter is equal to 1 centimeter cubed. Okay? Centimeter cubed is a unit that's derived from the volume of a cube, right? When I find the volume of a cube, what do I take? Length times width times height, right? So if this is 1 times 1 times 1, the volume of that cube would be 1 centimeter cubed, right? And that would also be an equivalent volume to 1 milliliter, 1,000th of a liter. So these are 2 units that are used interchangeably, and they're identical to one another. That's kind of an important piece that we need to know. So maybe highlight that one, star that one. But that's an important conversion that we will use a lot. So let's answer this question then. How many 1 liter is equal to how many centimeters cubed? Yeah, it would just be 1,000 because we know there's 1,000 milliliters in a liter, which means there must also be 1,000 cubic centimeters in that. Okay? We can use temperature in degrees Celsius, but there's an easy conversion to go from Celsius to Kelvin. Okay? If I need to convert from Celsius to Kelvin, I'm going to add 273. So I would take Celsius plus 273 equals Kelvin. Okay? So that means, does anyone know what temperature water freezes at in Celsius? It's at 0. So if I have 0 degrees Celsius plus 273, that means water freezes at 273 Kelvin. Okay? And then let's say I needed to convert back. What would I do if I wanted to go from Kelvin to Celsius? I just subtract 273, right? I would go Kelvin minus 273 equals degrees Celsius. Okay? You'll see that with these conversion factors, I always give the larger unit the 1, and then I tell how many smaller units are found in that, the same way I set up the metric system chart. I like to give the large unit the 1 because I don't like saying that like a centimeter is 0.01 of a meter, right? That feels messy to me. I would much rather say that in 1 meter is 100 centimeters, right? I don't like using a 0.01 or a 1,000th of something. I like to make sure that I know how many little things are in the big thing, okay? So you'll see me work through that. Let's go ahead and start some conversions here, okay? When we say conversions, that means we're not changing the quantity of our measurement. All we're changing is the unit at which we label it. Okay, we're not changing the quantity. We're just changing the unit. Okay. Let's say if I want to convert from inches to miles. Okay, do you have your calculators out? Why don't you go ahead and grab your calculator if you have one. Okay. If I wanted to convert from inches to miles, let's think about how I could do that. Do I know exactly how many inches are in 1 mile? No, but what do I know? Right, I know how many inches are in a foot. Oops, sorry. maybe. I do know how many inches are in a foot, and I know how many feet are in a mile. So I can convert using a couple different things. Okay? If I were to convert from inches to feet, let's talk about what we know. I know that 1 foot is equal to how many inches? 12 inches. And I know that 1 mile is equal to 5,280 feet. So if you don't know either of those conversions or both of those conversions, make sure you write that down, especially the mile one. Okay, if you don't know that one, go ahead and write it down. Okay, so now let's say if I wanted to convert from inches to feet, would I multiply by 12 or divide by 12? What do you think? If I wanted to go from inches and find out how many feet that is, would I multiply or would I divide? I would divide, because think about 36 inches should be a smaller number of feet. Agreed? Right? If there's 12 inches in a foot, I would take 36 divided by 12 and I get 3 feet. Right? Then if I wanted to convert to miles, would I multiply by 5,280 or divide by 5,280? I would divide by 5,280 feet, and I get a value of 3 divided by 5,280, 5.68 times 10 to the negative 4, or 0.000568 miles. Now, does that answer seem reasonable? Were we expecting here to have a small number of miles based on only having 36 inches? Yeah, right? I want you to be thinking about your answers in terms of, am I expecting a big number here or a small number? Okay? And so in this case, we knew that 36 inches is not that much distance, right? About that. So that's not a very big fraction of a mile. Okay? So we knew we were expecting a really, really tiny number there. Okay? All right. Now I'm going to show you the way that I would like us to use to convert measurements. Okay? We don't need to do the ounces to pound ones. We're going to start now with the metric system conversion. And I'm going to show you the method I use to do unit conversions, because the way we just did it is not that efficient. Okay? We're going to switch and use a different method, but I want to show us how we get there. Okay, so let's say I want to convert from milligrams to kilograms. Milligrams to kilograms. Okay, we're going to draw what's called a T-chart. That's how we do conversions, is with a T-chart. Okay, and we always start our T-chart with what we know. You're going to hear me say that a lot. We're going to start our chart with what we know. So we go 142.2 milligrams, and we draw like a sideways T here. Okay? Now let's work back a little bit here and say, if I want to go from milligrams to kilograms, do I have an easy way to get there? Can I do that in one step? Look at your chart and say, does anywhere on your chart say how many milli is in a kilo? Does it ever say how many milli is in a kilo specifically? Or what did it go between? It needs to go to regular units. So I can't just go from milligrams to kilograms. I need to go milligrams to grams, then to kilograms. Right? Because I don't know how many milligrams are in a kilogram. I know how many milligrams are in a gram, and I know how many grams are in a kilogram. So I can do it in 2 steps. Okay, so here's how a T-chart works. We need to think of it as a series of fractions that are being multiplied together. Okay, a series of fractions that are being multiplied. And if I have something in the numerator and in the denominator of a fraction that are the same, what happens to them? They cancel each other out. And so that's what we're going to try to do with our units. We're going to try to cancel our units out so that we can get to the desired unit. Okay, and so we always start our T-chart with what we know, milligrams. And we said we want to get rid of milligrams and go to grams. So if I want to get rid of it, it needs to go on the bottom. What I go to needs to go on the top. Okay? Then I draw my T, okay, or I draw another section of my chart here. So now if I'm looking at this as a series of fractions, I've got milligrams in the numerator and milligrams in the denominator, so those units would cancel. But now we've got to put the numbers with it. So I want you to look at your chart and say which one of these units should get the 1. Is gram the larger unit or is milligram the larger unit? Okay, so gram is the larger unit. It's going to get the 1. And then I need you to tell me how many milligrams are in 1 gram. 1,000, right? Look on your chart. It says 1,000 milliunits are in a unit. Okay, so now if I did the math right now and I divided by 1,000, my unit would be grams. But that's not what my problem asked me for. It asked me to go all the way to kilograms. So I'm going to keep going in my T-chart and get rid of grams and go to kilograms. Okay, and we're going to do the same thing now. We're going to put the numbers in. Which of these units is the larger one? Kilograms, that gets the 1. And then how many grams are in a kilogram? 1,000. So now essentially what I'm having to do here to convert from milligrams to kilograms is divide by 1,000 twice. But when we look at our chart, we only do the math one time. We make sure our units cancel. They're always going to cancel diagonally like that. So grams are canceled. Milligrams are canceled. I'm left with kilograms, which is what I wanted. Okay, the unit that I want to end up with should always be here in the top right of my chart. So now let's finish here with the math, right? When we do conversions, we put it in the chart and then we only have to do math one time. So when we converted from inches to miles, we did divide by 3 or divide by 12, then divide by 5,208, right? We did it in 2 steps, but now we're just doing the math once. So we take 142.2, divide by 1,000, then again divide by 1,000. Okay, when multiple things are in the denominator, you either need to put parentheses around it to do 1,000 times 1,000 in the denominator, or easier for me, I just do divide by 1,000, divide by 1,000, and then I hit enter. Right? Because I multiply across the whole top. Do I need to plug in times 1 times 1? No. Right? I take 142, divide by 1,000, divide by 1,000, and I get either 1.42 times 10 to the negative 4th or 0.001422 kilograms. How many centimeters are in 0.48 kilometers? So let's determine here, first of all, do you envision yourself getting a really big answer or a really small answer? Really big, right? Think about, you've got a half a kilometer, so there's going to be a ton of centimeters in there, okay? So we're going to go 0.48 kilometers. And I'm going to draw my T, right? Because I always start my chart with what I know. The number I'm given, right? I always start with what I know. Now let's map out, how can we get from kilometers to centimeters? Kilometers to, not grams, but what's the simple unit for length? Meters, then to centimeters. Do you see why we have to kind of stop there in the middle? Right? This is actually, on our chart, it actually goes from top to bottom, right? So we're going to cross over that simple unit, which means we need to stop there. And then we'll go to centimeters. So if I want to get rid of kilometers, where does it go? On the bottom. And what did I say I was going to go to? Meters, right? I can't go directly to centimeters there because I don't know how many centimeters are in a kilometer, right? I don't know that. If I did, I could do it in one step, but I don't. So now let's put in my numbers here. Between kilometers and meters, which one gets the 1? Kilometers, and then how many? There's 1,000 meters in a kilometer. So if I stopped and I did the math right there, kilometers canceled, but what unit would I be in? I would be in meters, right? I would be in meters if I stopped, and that's not what I want my final answer in. So I keep going, and I get rid of meters and go to centimeters. Which unit here gets the 1? Meters. And how many centa are in that unit? 100. Very good. So now I look to make sure my units canceled correctly. Meters, kilometers. I'm left with centimeters, which is what I wanted. So So I'm going to go do the math. Now I multiply across the whole top, divide by the whole bottom. So 0.48 times 1,000 times 100 gives me 48,000 centimeters. Okay, there's no need for me to plug into my calculator, divide by 1, right? That's not a need for me there. You'll notice in your chart, this section of our chart, this first underneath, this just stays empty. It's almost like it's over 1. Okay, so you don't need to bother writing anything there. Some people, for some reason, like to write their answers right there. I don't know where that came from, but that's not how it goes. Okay, so just leave that one blank. Okay, why don't you go ahead and try this one on your own? 4.24 kilometers to nanometers. Nanometers. Okay, go ahead and try that one on your own. On your chart there, 1 times 10 to the 9th, 1 times 10 to the 9th is the same as 1 with 9 zeros after it. Okay, so what is that? 1,000, million, billion. What do you have to know first about a leap year? It has an extra day. So how many days does that mean is in a leap year? Everyone's like 366. Normally 365 days in a year. A leap year would be 366 days. Okay, so what do we think our path is going to be to go from days to seconds? Days to hours, then minutes, then seconds. Very good. Okay, so go ahead and get that started. I'm going to do it up here on the board, but I'll be quiet. Okay, you might need both sides of that. It just kind of depends on how we can walk through that. So, inches to meters. Do we have an easy, like, one-step path to convert from inches to meters? No, but we've got 2 different ways we could go. Okay? I could go from inches to what? I could go inches to centimeters. Then I could go centimeters to meters. Or I could go inches to feet, because I have the conversion from feet to meters. It makes no difference which of those paths you choose, right? It doesn't matter. So let's go ahead and just do this inches to centimeters path first, and then I'll show you if we use the other one, it works out the same. So if I go 4.32 inches to centimeters, then centimeters to meters, I go and fill the numbers of these sections of my T-chart directly from my unit conversion chart, right? Those come directly from that. So my, how many centimeters are in 1 inch, or how many inches are in 1 centimeter, right? Which one here gets the 1? Inches gets the 1 right off your chart, and there are 2.54 centimeters in that inch. Okay, so if I stopped now, what unit would I be in? If I just did the math right now, I'd be in centimeters, but that's not what I want. I want to go all the way to meters. So right here, which one gets the 1? Meters. And how many centimeters are in 1 meter? 100. Okay, so to do the math, you multiply across the whole top, divide by the whole bottom.